Hi all, welcome back to Physics Login. In the last session we have studied units, different types of units, classifications of units, that is fundamental and derived units and practical units. All those things we have studied in detail in the previous session. In today's session we are going to study measurement of length, that is concept of length. So what is length? Length and how can we measure it? Length is the distance between two fixed points, right? If you want to measure the length of this pen, what you will do? From this end to the other end, you will measure the distance, right? So if there is two fixed points, you are measuring the distance between these two. That is length, right? So length can be measured in two ways. One is direct method and other is indirect method. So length measurement can be done in two ways. Direct method indirect method. In direct method, suppose, as I told you, length is the distance between two fixed points. If these two fixed points are conveniently within our reach, we can use the direct method. If any one of these points are not convenient to reach, we use indirect method. Examples I will tell you. If you want to measure the length of this board, what will you do? You will take a meter scale and you will measure it, right? Directly you will measure it because these 2 points are within our reach. So we can use meter scale, vernier caliper, screw gauge, you can use these instruments to measure the length directly if those 2 points are within our range. Okay, so what is indirect method? Indirect method is if any one of this point is not in our range, we cannot reach those points conveniently, we use indirect method. What actually we are using it, we use our logic and some mathematical calculation to estimate that distance. That is indirect method. For example, if you want to measure the length of a 2 kilometer long thread, okay, one indirect method, it is very difficult. If you take a meter scale and measure like this, it is very inconvenient, right? So what you have to do is you take a rod of radius r, okay, you take this rod and wind that thread over the rod like this, okay, and you count the number of turns on the rod. If number of turn is n, 100 turns are there, and if you know the radius, the circumference into number of turns will give you the length of that thread. So suppose 2 pi into r, this will be the rate, because you are using here, you are using your logic and the mathematical calculation to find the length of that thread. Such methods are indirect methods. So a lot of indirect methods are there. For in your syllabus, we have to study 2 methods. One is parallax method, parallax to estimate distance of stars or planet from Earth. If you want to measure the distance of a planet or a star, we cannot reach the other point. One point is at the surface of Earth, the next point is on that star. It is not convenient to reach at that point, right? So we use indirect method, our logic and mathematical calculation. This is that method, that is parallax method. Okay, then one more method is you have to study to measure small distance, very small distance, like measuring diameter of molecules. If you want to measure the diameter of a molecule, we have to use one experiment. I will explain that in the second stage. First, we have to study parallax method, and second, we have to study measuring the diameter of a molecules. Okay, both these are indirect method. Here we use our logic and some mathematical calculation to estimate such distance where we cannot reach the one of the points or both the points conveniently. Okay, so first is parallax method. First, we will understand what is parallax. Then we apply this logic and calculation to find out the distance of star from Earth's surface. Okay. So, what is parallax? Parallax is the apparent shift of the position of an object. Apparent shift of the position of an object when it is viewed from two different locations. So if you are observing an object from two different locations, you will feel that the object is shifted its position. Apparent means it is not real. Actually, the object is remaining at the same place, but you feel that it is shifting towards one direction because you are observing that object from two different locations. For example, if you look an object with your one eye closed, you can see the position of the object. Then again you observe that object with your other eye, you can see that the object is shifting. You can try this. Why? The object is shifting means you are observing the object in two positions, right? Two positions, because there is a space between, there is a distance between your eyes. If you're looking at from this, right, your point of observation is this, and then you are shifting the location, right? Then apparently the object will shift. This phenomenon is called parallax. Okay, look at this. One more example I can teach. One is, if this is a rod and at a distance one tower is there. In front of that tower, one small tree is there. Okay, so first you are observing these two objects, one tower and a tree, from this side. Okay, so your line of sight for this thing, this tower and tree will be like this. So from your observing from this point, the tree is on your left side. Sorry, the tower is on your left side and tree is on your right side, correct? After some time, so you have reached here. Again you are observing this, look at this. You can feel that now the tree is on your left side and the tower is on your right side, right? It shifted its position. Actually, the tree and the tower is not moving. You are shifting your location. Because of that, you will feel that the location of the two objects is changing. This phenomenon is parallax. Okay, if this is the base, okay, this A to B is your base, and this is your distance r, and this is theta. This theta is called parallax angle. Okay, parallax angle. For example, you draw like this. Take, this is your first location A, this is your second location B, and this is your object, and you're observing from here and here, and this is base, and this is suppose radius, and this is theta. So we can, if this distance is very large, you can treat this as a part of a circle, right? So we know that theta is equal to arc length by radius, right? So B by R. Using this calculation, we can find out the distance star and Earth. Okay, the distance between star and Earth using this principle. Now, parallax is parallel. What is parallax? It is the apparent shift of the position of an object. Apparent shift of the position of an object when it is observed from two different locations. Apparent shift. Apparent means it is not real. Okay, not real. Actually, the position of the object is not changing, right? You are fixing this machine. You are just observing from two different location, because there is a space between your eyes. Once you are looking from with this eye and next time you are looking with this eye, okay? So your locations of observation is changed. That is why you can feel that the object is shifting its position. That is apparently actual position. In actual practice, it is not moving. So the definition will be apparent shift in the position of an object when it is viewed from two different locations. Clear? Okay. Estimation of the distance of a near star from Earth by parallax method. By using parallax method, you know the parallax method, what is parallax? And using that method, we can estimate the distance of a near star from Earth. What is near star and far star? Near star means the distance should be, suppose D is the distance, should be less than 100 light year. That is called near star. Okay. Far star means if the distance is greater than 1000 light year, that is far star. Okay. We consider that is a very far away star. So we can use parallax method only those stars which is at a distance less than 100 light year. Okay. That is the disadvantage of parallax method. So in 10th grade you have studied that the rays from an object is at infinity, the rays will be parallel, right? I'll explain that thing. If this is an object, okay, you're observing this from this point and this point, look at this. This object will make a visual angle with your eye, and this will make theta 2, this is theta 1, okay? This object will make this is your eye position, okay? So it will make an angle. This object will make an angle that is called your visual angle. So when the distance increases, look at this angle is reducing, right? Reducing means you can see the object in smaller size. If the visual angle is bigger, the object will, you will feel that the object is bigger. Okay. So what happens when this distance increase, suppose it is increasing, the angle is decreasing, right? The angle is decreasing again. What if this object is observed from 10 kilometers away? This line will be approximately parallel, right? So if the object is very far away, the rays coming from that object will be parallel. So if we consider in this method, if the distance is greater than 100 light year, we consider it as a far away star and the rays coming from those stars are parallel. Okay, the actual method is we compare the rays of that far away stars and nearby star. Then we will calculate, we will use parallax method to find the distance between the near star and Earth. Okay, this is how it is done. Okay, so to do that, consider this is Sun and Earth is revolving around Sun in an elliptical path, right? Okay. Suppose the Sun, Earth is here, E, and so what will be the nature of the light ray coming from far away star? It will be parallel, right? Suppose these are the rays coming from far away stars, okay? And your near star is here. What you have to do, you have to compare the light rays from far away star and near star, okay? Suppose this is the light ray coming from far away star and one ray of light is coming from here, and you observe these two rays with a sextant. You can measure this angle, theta 1. There is a device which can measure this angle, which is called sextant. Okay, you will get theta 1. And if this is the center line, these two lines are parallel. If this is theta, this angle will also be theta 1. Clear? You measure, now you got this angle. You measured this angle, and after that you wait for 6 months. After 6 months, what happens? This Earth will rotate and it will reach here, right? Diametrically opposite, because This is the 6 months is the time taken for half a revolution of Earth around the Sun. So it has reached here. Now again we use the same step. You measure, you compare this ray and a ray from near star and measure this angle theta 2. So if this angle is theta 2, this will also be theta 2. Okay. So now you are getting a similar thing, right? In parallax theorem, we have the equation. What is this equation? This is B. So what will be this equation? This distance. This angle is theta 1 plus theta 2. Let it be theta. Okay. What will be this distance? You know this distance. What is the average distance between Sun and Earth? The average distance between Sun and Earth. We have studied this in the previous lecture. That is 1 astronomical unit, right? 1 AU. This also 1 AU. So total 2 AU. 2 AU. Astronomical unit. This angle is theta and we have to find out this angle. That is the distance of the star from Earth. Distance of the star from Earth. Okay. So this, let it be D. We know that from the equation we can calculate what is that? Theta is equal to arc length. Here arc length is equal to 2 astronomical unit divided by D. You got the equation now? What you have to find out from this and make the D subjective, because we have to find out D. So D, making D subjective, D will be equal to 2 AU by theta. This is your formula. Okay. One thing you have to be careful. This theta will be very, very small angle, right? This theta will be in seconds, arc seconds. I have explained degrees, arc second, arc minute, then the conversion, everything in the previous video. You can check that video. Then this should be in radians. The theta should be in radians. So here you have to convert that. Okay, we will take one example. If this angle 1 second and if this angle is 2 seconds. So theta 1 is 2 seconds plus theta 2 1 second is equal to 2 plus 1 3 seconds. Total 3 seconds is theta. Okay. How can you calculate this value? I'll do the calculation. So D is equal to 2 into what is astronomical unit? 1 astronomical unit, it is equal to 1.49 into 10 raised to 11. You can take that approximately 1.5 into 10 raised to 11 meter. Correct? Divided by this theta. You have to convert into, this should be in radians. Okay, this is in second. So you have to convert the second into radian. 3 seconds. Okay, 3 seconds into. The conversion is explained in the previous video. You can check that video also. One more time I will explain. 3 seconds into. First you convert this into minute because 60 arc second is equal to 1 minute. So 1 by 60 you have to multiply. Again, now it is becoming minute. Now you have to convert minute into degree. So that is also 1 degree is equal to 60 arc minute. So 1 by 60. So this much degree is the theta. Now it is converted into degree. Then how can you convert degree into radian? Just multiply pi by 190. Okay. Clear? 3 into 1 by 60 into 1 by 60 into pi by 190. You substitute that value here. Okay. 3 into 1 by 60 into 1 by 60 into pi by 180. So 1, 2, 3, this will go upside and it will be 2 into 1.5 into 10 raised to 11, 12, 13, 14, correct? 14 into 6 into 18 divided by 3 into pi, correct? This is also 3, this is also 3, right? 2 into 1.5, 3, and you can cut this, take this as 3.14, you take it as 3 and 2, and this will be 12 into 18 into 10 raised to 14. Do the calculation. This will be the distance of that star from Earth. If the angle theta 1 is 1 and theta 2 is 2, total angle theta is equal to 3 seconds. Then you substitute those values, convert that. Conversion is important. You have to convert that second into degree, radian. Theta, always theta you should substitute in radian only. Remember that. Okay, clear? So this is how we can apply parallax method to find out the distance of a near star from Earth. Clear? Next is measuring the diameter of a molecule. Okay, we have studied that measuring very long distance, that is distance between a near star and Earth, we used the parallax method. Now how can we measure very small distance? Very small distance means the diameter of a molecule, right? We cannot reach those 2 points. If suppose this is an enlarged view of a diameter of a molecule, we have to measure the distance between these 2 points, right? Because this size of the molecule is so small such that we cannot reach these 2 points. Here we use the indirect methods, that is our logic and some mathematical calculation to find out the diameter of a molecule of a substance. So that we use some mathematical calculation, that is the volume of a substance is equal to, what is that? Length into breadth into thickness, correct? Suppose we are taking a very thin sheet, that is very thin, okay? Thickness of the sheet is very thin, okay? The volume of this sheet of material will be equal to length into breadth into, this is the thickness. Very small thickness. So by any means, this is our logic, we have used indirect to find out the indirect measurement of molecule. Okay, this is the logic. That if by any means we are able to make the thickness of that substance which is equal to the diameter of the molecules, then if we find the T means we are finding out the diameter, right? By any means, we have to find a way for that. By any means, if the thickness is equal to the molecular size of that substance, we can find the diameter, right? So T will be equal to, what is the formula? T will be equal to V by L into B. That is volume divided by length into breadth. What is that? Area. That is thickness. So this thickness, if we are able to make this thickness which is equal to, that is we have to make that surface so thin such that that thickness will be equal to the molecular size. So that is our aim now. We have to make a substance such that the thickness of that sheet, make it as a sheet, very thin layer of the substance, such that the thickness will be equal to the diameter of the molecules. And then find out the volume of that substance, then find out the area of the substance, then you can substitute in this equation, you can calculate the diameter, right? Yes. For that we choose one particular substance, that is oleic acid. OLEIC, oleic acid. OLEIC, okay, oleic acid. And this oleic acid actually is a naturally occurring fatty acid which is present in animal fat and vegetable oil. Okay, that acid, that material we are choosing because this has two properties. One, less density. Two, high molecular size. These two property helps us to make this substance to very thin layer such that the thickness of that oleic acid layer will be equal to the molecules of oleic acid. How can we make that such a very thin strip? That is our next step. Okay. So this is our equation. Remember this. T is equal to volume by area. This T will be equal to D also, diameter. This is our formula. First we will make a very thin solution. That is, you take oleic acid and mix with the alcohol such that its dilution will be 1 by 20 part. Okay, 1 by 20 part. So that is, if you're mixing that oleic acid with the alcohol, dilution will be 1 by 20. Okay, after mixing, if you take 1 ml of, suppose 1 ml of that solution, it should contain 1 by 20, only 1 by 20 of oleic acid. Okay, then you have done that mixing. Again, you take that solution, which is 1 by 20. Oleic acid is presence is only 1 by 20. Again, you dilute it with the alcohol, again into 1 by 20 part. So total dilution will become 1 by 20 into 1 by 20 is equal to 1 by 400 part. Okay. So total dilution of the oleic acid alcohol mixture will be 1 by 400 part. Part means you have a 1 liter solution of oleic acid and alcohol mixture. If you take 1 ml of that, means that 1 ml contain only 1 by 400. That is, divide that 1 ml into 400 parts, only 1 part contain oleic acid, that much diluted. What happens when you dilute that substance? That intermolecular force, right? The thickness between the molecules will be diluted, will be reduced, right? So that is our first step. After dilution, you take that solution into a burette, right? Burette, you know that the burette you can find this in chemistry lab. Okay, there will be marking on this burette, and you slowly open this knob. This solution drop, it will come out, right? The solution will come out as droplets. So you count these droplets for 1 unit of the burette. For example, you are taking 1 ml and you are counting this drop for 1 ml. You found that the drops will be 20, not 20, take it be 15. For 15 droplet, 1 ml is coming out. So what will be the volume of 1 drop? For 15 drop, 1 ml. So for 1 drop, it will be 1 by 15 ml, correct? So 1 drop of the solution contain 1 by 15 ml. This is just an example, okay? You arbitrarily chosen value. If you do the experiment, you can use the original value. You measure that for 1 ml, how much droplet are coming. You count that and divide it, you will get the volume of 1 drop. Okay? So this is 1 by 400 part. Remember all these values. Let small v be the volume of 1 drop of solution. So volume of 1 drop of that oleic acid and alcohol mixture is V. Okay? So after this calculation, what you have to do is you take a big trough, a big container, very long big container, and fill it with water like this. This is filled with the water. Okay? So next step is you pour those solution, the diluted solution, into the surface of water. And while dropping it, pouring it, you have to count the drops. Okay? By drop, you count. Okay, what happened? It will fall here. So you will get a patch of solution, a patch of oleic acid solution. This is 3D, okay? Oleic acid solution on the surface of the water. So you'll get a very thin layer of this solution. The moment it is exposed to air and water, the alcohol content in the solution will get evaporated. What is the remaining thing? The remaining is oleic acid molecules only, right? Yes. So this molecule is actually, when you pour, the molecules will fall like this, right? Above this, above this, above this. It will be like this. Correct? Correct? Then what happens is, this is a very diluted quantity, right? There is no stickiness between the molecules of oleic acid. What happened is, gravity is acting on each molecule, right? So this will come down, and this molecule will push these two molecules apart. And finally, all these molecules will become like this. It will fall on the surface, spread on the surface of water like this, with a thickness which is equal to the diameter of molecule. Clear? Next, you got first task you have completed, that is, you have made a thin layer such that the thickness is equal to the diameter of the oleic acid substance. Next, what we have to find volume and area. Next, find volume. So to find volume, what you have to do? You have already counted this number of drops, right? So the number of, let n be the number of drops. Acid solution, okay? That is a mixture of oleic acid and alcohol. So if V be the number of one, small v the volume of one drop, we have poured n drops, so into n, that is the total quantity we have poured. Out of that, how much is oleic acid? 1 by 400, right? So into 1 by 400. So this is the total volume of the oleic acid molecules. So we got the capital V, that is small v into n into 1 by 400. You have this thing, right? So what you have to find out? You have to find out the area of the surface. Look at this. If it is a circular one, we can easily find out the area, right? Measure that radius and you can calculate using the formula. But here it is not a circular one. It is a different shape, not definite shape is there. So you have to measure this area. What you have to do is, you have to take a graph paper and dip that paper on the surface like this. Like this, you have to dip on the surface. What you will get? You will get a patch of the shape of that oleic acid surface on the graph paper, correct? Then what you have to do is, suppose this will be the shape of oleic acid you have got on the graph paper. This is your paper. So this graph paper contains columns, right? 1 mm square, columns, right? So each column is 1 mm square, correct? You count the number 1, 2, 3, 4, 5, 6, 7, 8, 9. You counted that number of column squares is equal to n. If the number of squares in the patch is equal to n, when you count, if a square contains more than half, you take it as 1. If it is less than half, look at this, only a part is in this line, you don't count that. This is more than half is counted, you count this thing. Make a rule for that and you count it, and this n into 1 mm square will be the area. Now you got the area also. Area you got, volume also you got, right? Now what you have to do? Apply the equation. Thickness is equal to the diameter. We already made that. This is equal to, the thickness will be equal to diameter. That will be equal to volume. You have the formula, small v into n into 1 by 400 divided by capital N into 1 mm square. Do the required conversions and you can calculate the thickness of one molecule of oleic acid substance. Okay, this is the method to find out the diameter of a molecules of a substance. Clear? Do 2-3 times the calculation. Take the average value, you can find out the diameter. These are the two things, parallax method and determining the diameter of a molecule was the two indirect methods which you have to study in grade 11. Okay, so we have studied direct indirect method. In that indirect method we have studied parallax and measuring the distance of a nearest star using parallax method, then determining the diameter of a molecules of a substance. All these things we have studied. In the next class we will study error analysis and we'll do the very good numericals in that part of your chapter. That will be the third video for second chapter. And till then, bye, take care, study well.